All right, lesson 1.3. We're looking at this picture on the second page of your notes, example 1. Okay, let's talk about some notation. So far with functions, we've seen this, or we rewrite this. What does f of x mean? Y. It also means y. Okay, that is a function.
Should we write it?
Okay, nope. That is a function. Now we're going to talk about piecewise functions. Piecewise functions, that means we're dealing with more than one function at a time. Okay, so looking at this picture right here, how many functions do you see in that?
4.
Hint, these two go together as one.
2.
So how many functions do you see?
2.
There should be 2. There's one function, and here's the second function. So we have 2 functions that we are looking at instead of just one. Okay, do we know what these right here are called?
No. Functions.
Nope, this is our functions. Over here, these are called our intervals. So we have our 2 functions, and then we have our intervals. Okay, so let's talk about what those intervals mean. Little review. What does this sign stand for?
Less than.
That is less than. What if I add a line underneath?
Everything less than. Isn't it
Less than or equal to?
There you go. Less than or equal to. Okay, and then if I have this sign, greater than, or if I add a line underneath it,
or equal to.
greater than or equal to. Questions about those signs? We're okay there? All right, let's look at the intervals here then. So this interval is saying 0 is less than or equal to x, which is less than or equal to 40. So what that's saying is x falls in between 0 and 40. Let me ask you this. Can 0 be in this interval?
Yes.
Why do you say yes?
Because it's 0 or 40.
Right. What does the sign tell me about it though?
It's less.
Or equal to, right? So since we have that equal to symbol right there, that means 0 is in it. Okay. What about 40? Is 40 in it?
Yes.
Yes, because
Or equal to.
has that equal to sign. Okay. Notice between the 2 intervals, I have 40 in both of them. Okay. Since this one has the equal to, 40 is considered in that one. Okay. With that second interval, it says x is greater than 40. Give me an example of x greater than 40.
X equals 50.
50, right? 60, 80, all of those. Okay, so that's what these mean. Let's plug in a value. So if I plug in, let's do x equals 40, for example. What do I mean by substitution? When you hear the term substitution.
Like a substitute teacher.
Okay, think if I tell you substitution with x equals 40, what would you do with that?
Plug it in.
Plug it in, right? That's what we're doing today. We're plugging in values. But first, with these, we have to ask ourselves which interval it falls in, and then that tells us which function to use. Okay, so x equals 40. Does that fall into the first interval or the second interval? Show me 1 or 2 on your hand. Does it fall in the first interval or does it fall in the second interval? Should be showing me 1. Why is it in the first and not the second?
Because the second has to be greater than 40.
Right, the second has to be greater than 40, but the first one, it can be equal to 40. So we are picking the first one. Since I picked this interval, that means this equation or this function is activated. So we're going to substitute 40 in for that equation. So I'm going to have 12 times 40, which gives us 480. So 480 is our answer. Okay, so the steps to follow is you're picking which interval, and then from there you're substituting into that equation. Okay, we picked this interval, so we're substituting into its equation. Does that make sense? So this interval goes with this equation, this interval goes with that equation. Okay, go try A on your paper. So A, it says, if I'm doing, what was it, 43?
Yes.
If x equals 43, we have to pick the interval first. Well, ask yourself, if I'm looking at this one, is 43 in between 0 and 40? No. Okay. Is 43 greater than 40? Yes. So which equation are we picking? This one, right? So if I plug that in, 37 hours, treat that as x equals 37. And then also try B, x equals 43. Okay? Go try both of those. Follow the same steps. So let's look back. Someone tell me what I need to write.
18 parentheses, 43 parentheses minus 240 equals 534.
You should get 534. Okay, so depending on what interval you pick is what equation you pick. Okay, the interval activates what equation you choose. Yes.
So once you choose one, that means the other one doesn't matter anymore.
Correct.
Okay.
Yep, correct. Yep. Want to talk about real quick this function right here. So this piecewise function, think to yourself, don't say it out loud, how many functions are in that piecewise function? Show me on your hands. 1, 2, 3, 4, however many. How many functions are in that piecewise equation? Many of us are showing me 3. Where do we get 3 from? There's 3 different equations, right? Why is it not 6?
Because like 4x plus 11 goes with negative 10.
Right. These two right here, they go together. Okay, so that's considered 1 because you always have an interval with some equation. Okay? I want to talk about something with this picture right here. Looking at this picture, how many functions do you think are in that picture? Show me on your hand. How many functions are in that picture? There is 3. Okay, it does match this function that we talked about up here. So this goes with the graph. That piecewise function goes with the graph. Okay, since we have 3 functions up here, we have 3 different functions in our graph. Okay, want to talk to you about something else. Looking at x equals 2, what do you notice? So this right here, what do you notice there?
2.
What?
They're lined up.
They're lined up, so that means they share the same x value. Do you agree?
Yes.
So the x value of 2 has 2 different solutions. What's the difference between them?
One's negative, one's positive.
One answer is negative, one's positive. What else?
One of them's green, one of them's blue, one of them's straight, one of them's not.
Okay, so do you agree it's 2 different functions?
Yes.
Okay, so because one's blue, one's green, that's 2 different functions. There's one other big difference.
One has closed dots, one of them has open.
One's closed, one's open. So this is the value of x equals 2. I'm going to go back to our picture up here. X equals 2. Well, where do you see that in the intervals? Do you agree that it's in interval 2? That x equals 2. Yep, 2 is in here, and it's equal to, so that's the second function. If it's equal to, it has a closed dot. Okay, so since it was equal to, it has a closed dot. Well, what do you notice about this one?
It doesn't have an equal to.
It's not equal to, that's why it's open. Okay, so that's what the closed and open circles mean. So an x value can have a value in both functions, okay, but it's not always going to be open or closed. Okay, so the equal to, that tells you what it is. Questions about those little things? Okay, let me ask you this. Negative 2. X equals negative 2. Which interval does that fall in? Or intervals?
The second one.
Okay, I have negative 2 here. What does this mean?
Or equal to.
It's equal to, so that means it would be a closed dot for my second one. Do you agree? But is it also in the first one?
Yeah.
But is it going to be open or closed?
Closed, open,
It's going to be open. Why?
because there's no line underneath.
There's no line underneath. There's no equal to.
I would call them an x-axis.
Okay. It's always going to be x's because remember f of x is
Oh.
y. So it's always going to be x values in your function. Good question. Yep. We are following that first one up there. Does that match your A? Yes. Okay, so with these, and if I have my coordinate plane, I'm going to use this as my coordinate plane. How far apart are your guys'? 5? Okay. What values are we plugging in again? X's or Y's? We're plugging in X, so we're going to test all of these X values. Okay? It will take time, okay, but it's good practice. We're testing all these X values. I'm going to always start at the left because we always read left to right, right? Left to right. What is my least X value on the coordinate plane? What's my least X value?
5.
Negative 5, right? Does everyone agree? Negative 5. That's my least X value on your graph. So, negative 5, I need to pick which interval negative 5 goes into. Think of it this way. Is negative 5 in between negative 6 and negative 2?
Yes.
Yes. Okay, I'm going to keep going. Is negative 5 in between negative 2 and 1?
No.
No. Is negative 5 in between 1 and 3?
No.
No. So we're picking this one. Does everyone understand why I picked this first interval? Okay. Negative 5 is in between negative 6 and 2. So since I picked this first interval, what equation am I going to use?
2x plus 5.
Yes. So I'm plugging in negative 5. So I have 2 times negative 5 plus 5. Well, let's solve. What's 2 times negative 5?
Negative 10.
Negative 10 plus 5?
Negative 5.
Negative 5. Now, that just gave us a coordinate. Let's think about it. Our coordinate here, what is the X value that we plugged in?
Negative 5.
Negative 5. What's the value that I got out?
Negative 5.
Negative 5. So that is my coordinate. Now go graph that on your coordinate plane.
Oh, is it a close dot?
Good question. Is it?
Yes.
Yes, because it's in that interval. Yep. So there is my first value. Okay. Now we're going left to right. What is my next X value?
Negative 4.
Negative 4. Which interval does negative 4 fall into? Show me 1, 2, or 3 on your hand. Negative 4 goes into which interval? Again, ask yourself what numbers it lies between. It is 1 because negative 4 is in between negative 6 and negative 2. So since I picked this first interval, what equation am I going to use?
2x plus 5.
The first one, right?
You can use the same ones over again.
Not necessarily. It just depends where the number lies. So I have 2 times negative 4 plus 5. What's 2 times negative 4?
Negative 8.
Negative 8 plus 5?
Negative 3.
Negative 3. Okay, let's think about what the ordered pair is. What's the X value that I plugged in?
Negative 4.
Negative 4. What did I get out?
Negative 3.
Negative 3. That is my new coordinate. And then I plot it. What is my next X value?
Negative 3.
Yep, we just did negative 4, so it's negative 3. Which interval does negative 3 fall into? It does fall into 1 because negative 3 is in between negative 6 and negative 2. So since we picked the first interval, what equation am I going to use? Yep. So we have 2 times negative 3 plus 5. What's 2 times negative 3?
Negative 6.
Negative 6 plus 5?
Negative 1.
Negative 1. What is my coordinate that I just made?
Negative 3. Negative 1.
Negative 3, negative 1. And then I go plot that point. Okay. What's my next X value?
Negative 2.
Negative 2. Negative 2. Which interval does negative 2 fall into?
The second one.
Okay, I hear 1 and 2. You're not wrong. Okay, but let's do the first one first because negative 2 is equal to. Okay, we know that's going to be open or closed.
Open.
Equal to is closed. Okay, so negative 2 is in the first, so we're going to use that equation right there. So we have 2.
How many times do we have to do this?
So what's negative 2 times 2?
Negative 4.
Negative 4 plus 5?
1.
1. What is my coordinate?
1, negative 2.
Switch it.
Negative 2, 1.
Negative 2, 1. Okay, we picked the first interval, but what do you notice about the second interval? Negative 2 is also the second interval, but is this one going to be open or closed?
Open.
Open. Okay, so I'm going to switch my colors here.
I thought it couldn't.
Okay, so now I'm moving on to my second function. We also need to test negative 2.
Okay, so that was just all for the first one?
Yep.
I thought it couldn't be negative 2 because that was not equal to.
Right, but the circle's going to be open.
I'm so lost.
Okay?
It can be as long as the circle's open.
We need to plug in negative 2 to our second function. So 2 times negative 2 squared minus 7. So now I'm in this function. What's negative 2 squared?
Negative 4.
4 times 2?
8.
8 minus 7?
1.
1. What is the coordinate I just got?
Negative 1, 1.
Nope.
Negative 2, 1.
There you go. Negative 2, 1. But when we graph that, is my circle going to be open or closed? Open. So I'm just going to make a little open circle around there. Okay? What's my next x value?
Negative 1.
Negative 1. Which interval does negative 1 fall into? Show me a 1, 2, or 3. It is 2 because negative 1 is in between negative 2 and 1. So since I picked this interval, I plug it into that second one. So I have 2 times negative 1 squared minus 7. What's negative 1 squared?
1.
1 times 2?
2.
2 minus 7?
Negative 5.
Negative 5. The coordinate I just got is
Negative 1, negative 5.
good. Negative 1, negative 5. And then go plot that. Negative 1, negative 5.
It's going to be open. Nope.
So it's inside the interval now.
Close.
So closed. Yep. Next x value.
0, 0.
0, right? So we're going to plug in 0. Which interval does 0 fall into?
All of them. Regular, well,
Is 0 in between negative 6 and negative 2?
no.
Nope. Is 0 in between negative 2 and 1?
Yes.
Yes. So we're going to use this equation here. So we have 2 times 0 squared minus 7. 0 squared is times 2. 0 minus 7.
Negative 7.
Negative 7. We do go off the graph a little bit, but it's okay. So we have 0, negative 7. So go ahead and plot that. We're almost done. What's my next x value? We just use 0. What's after 0? 1. Which interval does 1 fall into? Are we still in the second one? Could be, but our circle's going to be
Open.
open. So let's plug in 1 to the second one. 1 squared is 1 times 2.
2.
2 minus 7.
Negative 5.
Negative 5. So we have 1, negative 5. And did we say that's going to be open or closed?
Open.
Open.
I see a pattern.
Yep. Now, are we done with 1?
No.
Why not?
Because it could be, I don't know.
1 was in this interval. Is it also...
Oh, yes.
It's in the third one too. So we need to also plug in 1 to that second one, or the third one, sorry. So we have negative 4 minus 1. What's negative 4 minus 1?
Negative 5.
Negative 5. What is my coordinate that I just created?
1, negative 5.
1, negative 5. Well, what do we know about that coordinate? It's going to be closed. Yep. We're almost done. What's my next x value?
2.
It is 2.
Yeah.
I got off on my colors. It is 2. Which interval does 2 fall into?
But should we draw the line?
Oh, yep, you can. Which interval does 2 fall into?
The third one?
Right. Once you're in an interval, are you probably going to ever leave that interval until you have to?
No.
No. Okay. So if I plug in 2 to that third one, negative 4 minus 2,
Negative 2.
Negative 2.
Negative 6.
negative 6. What is my coordinate? 2,
Negative 6.
2, negative 6. We do it off the graph, but that's okay. So 2, negative 6 is about here. And now we have one more. Why do I know we have one more?
Because you can't go above 3.
Can't go above 3 because that's where our interval stops. Okay, so our last one is 3. So we plug in negative 4 minus 3.
Negative 7.
Negative 7. Our coordinate is 3, negative 7. So we fall here. And then you can draw your line. Okay, now I know that was a lot. Okay, again, I'm never going to make you do that. Okay, if I do, you're only going to have to plug in maybe 5 values. Okay, so the whole reason we did this was, one, for practice, to choose intervals and choose equations. Okay, but also to compare. How many functions did we start with?
3.
3. How many functions does our graph have?
3.
3, right? Does everyone agree? We started with 3 functions, and our picture shows 3 functions also. Okay? Let me find it. Okay, if I'm looking here on this first graph, think back to geometry. Is this a line?
Yeah, yes.
Yes, it's not straight. Sorry. Is this a line?
No.
Why not?
It's not straight.
Right, a line has to be straight. It cannot be like this. Okay, so how many functions do we have in that graph? We do have 3. Yep, we have 1 here, 2 here, 3 here. So on this graph, we have 3 functions. Everyone agree? Okay, ask yourself the same thing. How many functions are on B? Hold up with your hand. 1, 2, 3, 4, 5, however many you see. There is 3 functions. Why did you guys choose 3? There's 3 different lines, right? We have one function, another function, and then another function. Looking at this graph closer, okay, do you see x equals -2?
Yes.
Okay. Which function does -2 equal to? Show me 1, 2, or 3. We're only looking at 1 and 2. Show me which function has -2 in it, or is equal to -2. Go. It is not both. Addie, why did you pick 2?
It's close.
Right, it's a closed circle, so we know that this function is equal to 2. Why is this one not equal to 2?
Because it's open.
Because it's open, right? So it probably had like a less than or a greater than with no equal to sign. Okay, similar thing here. Show me on your hand. For x equals 1, which function equals 1? Which function equals 1?
The third one.
It is the third one. Why did you pick the third one?
Little circle.
Because it's a closed circle here. It's the, why is it open there?
Because it was a greater than 1.
Right, because it wasn't equal to. Yep, so looking at those 3 different things, awesome. I'm just going to ask you some questions like we were doing. Okay, looking at number 6. Show me on your hands 1, 2, 3, 4, or however many. How many functions does number 6 have? I'm looking at everybody, so make sure you're showing me signals. How many functions does number 6 have? It is 3. Good. I'm going to ask you this. Which function does 0 fall into? Show me on your hand 1, 2, or 3. Which function does 0 fall into? It is 2 because 0 is in between -3 and 3. Good. Which function does -3 equal to? Why is it the second one and not the first one?
Because the first one's on the equal to sign.
Closed circle or equal to sign. Yep. Where does -6 go? Which interval is -6 in? It is 1. Why is -6 in the first one?
Because it's between -10 and 3.
Because it's in between -10 and 3. Good. One more. Where does 6 fall? +6.
It doesn't.
Why do you say it doesn't?
Because it can only go 5.
Right, it only goes to 5. So anything greater than 5 is not in our piecewise function. Okay. You're number 7. So I'm looking at this one right here. What is different about this one? Right, there's no equation or there's no function, and you said there's 4 functions. In a piecewise function, is there a limit or minimum to how many there can be in there? No. Okay, there's always going to be at least 2 functions. Okay, so looking at that one, Aubrey said there's no equation. Is that true?
Yes.
What makes an equation an equation?
You get decimals. Plus, minus, divide.
Okay, plus, minus, divide, or you have to have what in there? What is it missing? It's missing an x, right? So if I ask you, where does 1 fall? Where does x equal 1 fall?
It doesn't.
Is 1 between 0 and 2? Okay, so 1 falls into this one. Well, what's my answer then?
I don't know.
Right, because there's nothing to plug it into. So it is just 1. So whatever number falls into here, its answer is always going to be 1.
So you can cheat it.
So this one, there's no algebra involved. It just tells you exactly what it is already. Okay? Where does 5 fall? 1, 2, 3, or 4?
3.
Where does 5 fall? It does fall into 3 because 5 is in between 4 and 6. So if I picked this interval, what's my answer?
5.
5, right? Where does 6 equal to? Where does 6 equal to? 1, 2, 3, or 4? It is 4. Why is it 4? Because it's equal to 6. Well, since it falls into 4, what's my answer going to be? 7. Okay, so it kind of makes your life easier when there's no x in there, right? It just tells you automatically what the answer is. Okay,